The White Knight itself is just a fantastic airplane. It's basically a 757 size airframe, dual fuselage. You fly from the right side, and the two fuselages are connected with one giant wing, 140 feet all the way across, and the whole vehicle's carbon fiber, including the cables that you use to control the flight control surfaces and the seats that you sit in. And that there's a big gap in between the two fuselages, and that's where you mount the spaceship. And that vehicle we've had up into the 50s, and it would probably go a lot higher. The news websites for Virgin Galactics, say I was the first commercial astronaut, but I didn't end up going to space. And we can talk a little bit about that story. I did spend 2 years there, 2.5, getting to test some really cool vehicles. One of them was the Mothership that hauled the spaceship up to altitude, and I also got to do some glide flights in the spaceship itself. It was all in the atmosphere testing, and the guys that came on after me got the chance to go do that, and are still at it actually on the commercial side. So
it's wild. How high did you fly?
So, when we were testing, this is back in the 2011, 2013 timeframe, White Knight and Spaceship were basically just starting their initial test evolution. They were a spin-off or the next level of what Burt Rutan and Skilled Composites had done back in 2004 in an effort to win what was called the X Prize. And it was a prize that's taken on different incarnations, but this particular one was take a certain amount of payload into space and do it 2 times within a certain time period. I think it was like a week or 10 days. And Burt took on the challenge and made some very unique vehicles. The cutting line for space is like roughly 330,000 feet, which is what they had to exceed. And he came up with this novel approach to win it, which was not to go out of the atmosphere and orbit, but basically go up, tag 3 or 4 minutes of 0G, and then bring the vehicle back in and land it, and then obviously get the cycle time down where they could do that a couple of times in a couple of weeks. And at the time, Richard Branson was very enamored with that effort, which ultimately was successful, and put in a bid with Skilled Composites in Mojave to go build these other 2 vehicles. But the White Knight itself is just a fantastic airplane. It's basically a 757 size airframe, dual fuselage. You fly from the right side, and the 2 fuselages are connected with one giant wing, 140 feet all the way across, and the whole vehicle's carbon fiber, including the cables that you use to control the flight control surfaces and the seats that you sit in. And that there's a big gap in between the 2 fuselages, and that's where you mount the spaceship. And that vehicle we've had up into the 50s, and it would probably go a lot higher. Engines, notwithstanding, the Pratt & Whitney 308s probably weren't meant to go that high for any significant amount of time. But anyway, we were up there. Yep.
Yeah, I got a couple questions. The pilot and me, just actually probably the fuselage piece of it. Is that weird or is that different? Is it? I would assume the flight controls had to be designed to make it pilot natural, for lack of a better phrase, to be operating sitting over here and then still have a bunch of mass off to the other side.
Yeah, that was one of the weirdest things. There was 3 or 4 of us that flew it, and sitting in the left seat, every once in a while you'd kind of look over to your left side and you would flinch because there's another fuselage flying perfect formation with you, and it's a welded Wingman, and it took 4 or 5 flights to get over that. But the real differences come in landing. That fuselage sits about 25 feet right of the center line, and Mojave's main runway is pretty wide. I think it's 150 feet. But you're landing offset, which for a fighter guy is not a big deal because you always do some staggered landings and things like that. But when you come into touchdown, you get this asymmetry, especially if you have a crosswind, where one side of the fuselage touches down first, and then the other side needs to be lowered gently. And you can easily fall into this habit of you touch down, you're done, you kind of relax on the controls, and you get a little bit of a hard drop on the other pod. And obviously we try to avoid that. So typically, even with our crosswind limits, which I think we're running around 15 knots, about the furthest up in the air that pod would be at touchdown of the primary, whether it was left or right, would be another 5 or 6 feet. But it definitely took some getting used to, and you got to fly it like almost like a tailwheel airplane because of the amount of side. Those fuselages are pretty long, and you get wind effects on them, so you got to keep the nose pointed straight, and you're kind of you're basically driving a big shopping cart because you have 4 wheels, 2 mains, 2 noses. And they don't all touch at the same time. So made for some fun challenges and lots of practice getting to do that.
I mean, there's no simulator for that. But I mean, that's part of being a test pilot, right? But man, that's wild.
Yeah, and that's really, I know you had like Cinco Hamilton on, and he talked about it. The test pilot school is really about brushing off your engineering skills and bringing you up to the level that you can communicate with the engineers in all the discipline areas. So master of none, but a little bit deep in each one. And then the other one is to expose you to flying lots of different airplanes, so that when you hopefully see some good and bad flying characteristics, you can adapt quickly, and then you can start to quantify what's acceptable for safety, what's acceptable for meeting the contract, and then ultimately, we segue into operational tests where can it do the mission? Is it suitable for that? So yeah, nothing really prepares you for some of these unique and novel, but I had a lot of tailwheel time. I think that helped. But the real challenges with White Knight are that it's a fully reversible flight control system. So no hydraulics. All the air loads on all the surfaces come back through the controls. And because of the long wing and big ailerons, it's got some pretty high forces, especially in roll. And so the controls are a little unique. They look like a stick, but on the top of the stick there's a yoke. It's basically 2 handles, but the yoke doesn't rotate. So you move the whole stick left and right to put in roll, but you actually have 2 handholds that you can hang on to do it. And that's just to aid with the forces. And one of our pilots, Forger Stuckey, who was at the time with Scaled Composites, we were kind of doing a hybridized test team approach, would actually reach across and grab the co-pilot stick as well, because that would give him a little more leverage. So if you're trying to get big roll rates on it, you might do some unique things to make it a little more palatable. But like I said, some really weird stuff with reversible flight control. So it's got cables, but cable stretch or contraction with a metal cable up at those altitudes and those temperatures is too much to handle. And so they went with carbon fiber, and they actually made cables out of carbon fiber, and they basically had no stretch. So you could make them as tight as you want onto the ground or whatever they needed to be, and then they basically held that same tension level up at altitude. So some really novel things that come out of that kind of test program.